This video is about drawing conclusions based on given information and using two-column proofs to prove that triangles are congruent. So remember that we have 5 ways to prove that triangles are congruent. We have side, 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 angle, side, angle, angle, side, angle, side, angle, and hypotenuse leg for right triangles. So as a review, let's look at these pictures and determine what method would prove the triangles are congruent. So in this case, if I have one right angle, remember that the next to it's also a right angle. We also have a shared side, AW, so by reflexive property, that would be congruent. So in this case, we have a right angle, a leg, and the hypotenuse, so we would be using HL to prove that the triangles were congruent. In the second one, we have a shared side, BS, so we have a set of angles, another set of angles, and one set of sides. The side is not between the angles, so in this case, this would be angle, angle, side. In the third one, it's a bow tie problem, so our bow tie problems always have vertical angles. So we have one set of sides with the circles, one set of sides with the tick marks, and our vertical angle that's touching both sides. So this would be a side, angle, side, because our angle is included between the two sides. The next one, we have two angles that are congruent. So we have the angle with the tick mark and just the angle arcs. We also have a shared side. So in this case, because the side is touching both angles, this would be an angle side angle method. And in the last one, we have a shared side CT that we can mark congruent by the reflexive property. We have two other sets of congruent sides. We have the ones with the tick marks and the ones with the circles. So we have 3 sets of congruent sides, so we would use the method side, side, side. So we're going to use these methods, and now we're going to prove that a triangle is congruent based off of given information. So before I start even doing my proof, I want to read through the given information what I have to prove. So I know that BA is congruent to TA, and that S is the midpoint of BT, and I need to prove that BAS is congruent to TAS. So first what I want to do is I want to mark the information they gave me. So I know that BA is congruent to AT. I know that S is a midpoint. Remember that midpoints bisect a segment into 2 congruent parts. So those are also congruent. And AS is congruent to itself by reflexive property. So the method we used here was side, side, side. So now that I've done my pre-work, I can go and do my proof. Remember, all proofs always start with writing the given statements again. So for the first step, we're going to write the 2 given statements. So BA is congruent to TA, and S is the midpoint of BT. This was given to us. Now, in step 2, this is already kind of filled out for us, so it's saying BS is congruent to ST because we can conclude that from our midpoint statement. So if we know that they're congruent, we're going to say that in the statement side, and then the reason we're going to explain that a midpoint bisects a segment into 2 congruent parts. And then remember that we also in our picture marked that AS was congruent to itself by reflexive, so we already have that reason, and in the statement we need to say that AS is congruent to AS. And now that I have my 3 pieces of information in my proof, I have my side, my side, my side to get our method side, side, side. The last statement is always your proof statement then. So in this case, we would have triangle BAS is congruent to triangle TAS. And our reason then is the method we were using, which was side, side, side. So let's try another proof. Given that A bisects CAT, so CAT is this whole angle, and AS bisects it, which means this angle here is congruent to this angle here. We are also told that CA is congruent to TA, and by looking at the picture, we can also mark AS is congruent to itself by reflexive property. So we have some of the steps written out for us, and we're going to fill in the rest of it. So the first statement is our given statement, and the reason is that it's given to us. Now, this statement, I can't do anything else with it, so I just take that. I know I have one of my sides. In statement 2, when I look at my triangle, we know we had to do something with this bisect statement, so we mark those angles. Now, when I write my statement, I can do it 2 ways. I can name the angles, or I can put numbers by the angles and just say that angle 1 is congruent to angle 2. And we already have the reason. A bisector divides an angle into two congruent angles. We also remember marking that AS was congruent to AS. So remember now, we have three pieces of information from our triangle. We have our sides congruent, angles congruent, sides congruent. So the method that we used here was side, angle, side. So in the last step, we're going to put our proof statement. So triangle CAS is congruent to triangle TAS, and our reason in this case would be side, angle, side. In our next proof, we know that there's now 4 steps, and it's not filled in for us, so we're going to fill in our own proof. So first they told us that D is congruent to I, and that V is the midpoint of EL. So remember, if V is the midpoint, it's bisecting this side into two congruent parts. And whenever we have bow tie problems, remember, we can also mark vertical angles. So the method we used to prove that the triangles were congruent, in this case, was angle, angle, side, because the side is only touching one of those angles. So now we're going to do our proofs. Remember, proof, we always start off with the given. So angle D is congruent to angle I, and V is the midpoint of EL. Remember, the reason is that that's given to us. Now, angle D is congruent to angle I. We can't do anything else with it. So step 2, we want to use something with the midpoint. Well, remember, the midpoint bisects the segment, so we can say that EV is congruent to LV, and our reason then is explaining the midpoint. So a midpoint bisects a segment into two congruent parts. Step 3, remember, bow tie problems always have vertical angles, so that's what we're going to stay in step 3. So we can name the angle with 3 letters, or again, we can just call it angle 1 and angle 2. So we can say angle 1 is congruent to angle 2, and our reason here would be vertical angles are congruent. So in this case, I now have 3 pieces of information I know about the triangle. I have angles, a side, and another angle. So now I can, in my last step, use that proof statement. So triangle DEV is congruent to triangle ILV, and our reason is angle, angle, side. So remember, all proofs should always end up with what method we're using to prove the triangles were congruent. So our next one, we have BD is congruent to, or is perpendicular to AC, and we have AB is congruent to BC. So remember, if we have perpendicular lines, they're forming right angles. So we need 2 steps about that. We need to identify the right angles and then say they're congruent. We also know that these sides were congruent because it was given to us, and we have a shared side, so we can use reflexive properties. So in this case, we use the method HL to show the triangles are congruent. So now we're going to start writing out our proof. So remember, the first step is our given. So BD is perpendicular to AC, and AB is congruent to BC, given. So step 2 now, we need to use that perpendicular thing, and we need to show we have right angles and that they're congruent. So first we're going to say that angle 1 and angle 2 are right angles. And our reason is that perpendicular lines form right angles. And then in step 3, now that we know they're right angles, we can say that they're congruent to each other. So we're going to say angle 1 is congruent to angle 2. And our reason here is that right angles have the same measure and are congruent. Then in step 4, we also need to mark our third piece of information, which is that BD is congruent to itself by reflexive property. Now we have our 3 pieces of information about our triangles, so we know that one of our sides were congruent, one of our angles was congruent, another side was congruent. So now we can make our proof statement because we have 3 pieces of information about the triangle. So step 5, triangle A BD is congruent to triangle CBD, and our reason here would be HL. So in the last proof, this one's a little bit tricky because we're looking at triangle CAN and triangle DYN. So the CD and the AY really don't have any point to be there. They're just there in our picture, but we're not going to use anything with them. So N is the midpoint of CY, which means that CY was bisected into two congruent parts. Same thing happens with DA because N is also a midpoint of that. And now when I look at the two triangles, I see a bow tie problem. So remember, I also have vertical angles are congruent. So I would use the method side angle side to show those triangles are congruent. So in step one, I need to say that N is the midpoint of CY. And I want to say that N is the midpoint of DA. Now, I can do the next step in two different parts or together because it's the same piece of information and the same reason. So in step two, I'm just going to say that CN is congruent to NY and DN is congruent to NA because it's the same reason that midpoint is bisecting that segment. So our reason here is that a midpoint bisects a segment into two congruent parts. Then remember, because it's a bow tie problem, we also have vertical angles. So step three, I can give these angles numbers. So angle 1 is congruent to angle 2. And my reason is that vertical angles are congruent. And then our last step, we can say that the triangles are congruent. So triangle CNA is congruent to triangle YND. And our reason here would be side angle side.